She discovered what stars are made of. She was 25 years old. She was right. Her supervisor told her she was wrong, pressured her to call her own findings spurious, to write, in her own thesis, that her conclusions were almost certainly not real. She did it. 4 years later, a man published the same findings, using different methods. He got the credit. His name is still cited in textbooks. Hers is not. This is the story of Cecilia Payne-Gaposchkin, the woman who rewrote the universe, and was then told to stay quiet about it. Cecilia Helena Payne was born on May 10, 1900, in Wendover, England. Her father, Edward, was a lawyer and a musician. He died when Cecilia was 4 years old. Her mother, Emma, descended from a distinguished Prussian family of scholars. She raised 3 children alone and made sure all of them thought. Cecilia read everything. The family had a library, and she used it. She taught herself botany. She memorized poetry. By the time she was a teenager, she was studying mathematics on her own because her school did not offer it. She got expelled from her Catholic school for being too curious. She spent a year working through mechanics, thermodynamics, and Newtonian equations before sitting her entrance exams. Then she got into Cambridge, in 1919. As a woman. That requires some context. Cambridge had been exclusively male for nearly 700 years. Women had been permitted to attend lectures since 1869, but they could not receive degrees. They could complete the coursework. They could sit the exams. They could outperform the men in the room, and then they could leave with nothing. Women would not receive Cambridge degrees until 1948. Cecilia knew this when she applied. She went anyway. At Cambridge, women were expected to study botany. That was the path. That was what was available to them. Cecilia began with botany, physics, and chemistry. She was good. She was not yet on fire. Then, on the night of December 2nd, 1919, she attended a lecture. Arthur Eddington, head of the Cambridge Observatory, stood up to describe what he had witnessed in Africa. The observation of stars near a solar eclipse, which had confirmed Einstein's theory of general relativity. The universe, he explained, was not what anyone had thought it was. The rules had changed. Cecilia was one of 4 women in the audience. She wrote later, "The result was a complete transformation of my world picture. My world had been so shaken that I experienced something very like a nervous breakdown." She raced back to her room. She transcribed the entire lecture from memory, word for word. She did not sleep for 3 nights. That night, in her room, she changed her course of study from botany to astronomy. The problem: Cambridge did not offer astronomy as a discipline. It was categorized under mathematics, and women could not officially enroll in mathematics. So she attended every astronomy lecture she could find, in addition to her existing coursework, and taught herself the rest. She completed all her studies. She received no degree. Cambridge would not give degrees to women, not for another 29 years. Cecilia understood what this meant. In Britain, without a degree, the only profession open to a woman with her qualifications was teaching. Not research, not astronomy. Teaching. That was not an option she could accept. She met Harlow Shapley, the director of the Harvard College Observatory, who had recently begun a graduate program in astronomy. She wrote to him. He responded. In 1923, she crossed the Atlantic and enrolled as a graduate student. She was 23. She had already completed full studies at Cambridge. She was starting over because the institution she had given her intellectual life to refused to acknowledge she had been there. At Harvard, she could not receive a doctoral degree either. Harvard did not grant PhDs to women, but Radcliffe College, the affiliated women's college, did. So Cecilia Payne worked at the Harvard College Observatory, conducted her research there, used its instruments and its photographic plates, produced her findings, and received her degree through Radcliffe. The work was hers. The institution required a workaround to acknowledge it. Before we get to the thesis, we need to stop here. The Harvard College Observatory had a specific history with women. Beginning in the 1880s, the director, Edward Pickering, had hired women to catalog and classify stellar data. These women were called computers. They were paid significantly less than the men around them. Some were paid as little as 25 cents an hour. Among them, Annie Jump Cannon, who developed the stellar classification system still used today. Williamina Fleming, who discovered the Horsehead Nebula. Antonia Mori, whose classification work built the scaffolding for understanding stellar evolution. These women are the Harvard computers. Their stories deserve their own video. Cecilia arrived at this institution. She joined it as a graduate student, as a researcher, as a woman working in a space where women had been deliberately underpaid and undercredited for decades. She knew the terrain. She was undeterred. Cecilia Payne's dissertation was titled Stellar Atmospheres, a contribution to the observational study of high temperature in the reversing layers of stars. She was 24 years old when she finished it. Here is what she was trying to solve. At the time, astronomers believed that stars were made of roughly the same elements as the Earth's crust: iron, silicon, oxygen, the heavy elements. The assumption was that a star was essentially a very hot version of the rocky ground beneath your feet. Nobody had actually proved this. It was assumption layered on assumption, calcified into consensus. Cecilia was not satisfied with consensus. She used the Harvard Observatory's photographic plates of stellar spectra, images of the light emitted by stars broken into their component wavelengths, and she applied an equation developed by Indian physicist Meghnad Saha. Saha's ionization equations could tell you, given a temperature and a spectrum, what elements were present in a stellar atmosphere and in what quantities. Cecilia was exceptionally skilled in atomic spectra. She understood something the other astronomers had missed, that a hydrogen line being faint in a stellar spectrum did not mean there was little hydrogen present. It meant the hydrogen atoms were in the wrong energy state to produce that line at that temperature. At the surface temperature of the Sun, only 1 in every 200 million hydrogen atoms would be in an excited enough state to produce visible absorption. So the spectrum was showing a tiny fraction of the hydrogen that was actually there. She ran the numbers for every element she could access. What she found was staggering. For most elements, the stellar abundances roughly matched Earth. But 2 elements were catastrophically off. Helium was thousands of times more abundant in stars than expected. Hydrogen was not merely more abundant. Hydrogen was 1 million times more abundant in stars than the prevailing theory predicted. 1 million times. This was not a minor correction. This was the complete overhaul of everything astronomers thought they knew about what a star is. Stars are not hot rocks. Stars are almost entirely hydrogen and helium. The heavy elements, iron, silicon, the building blocks of planets, those are trace components. Almost nothing, cosmically speaking. The universe is not made of what we are made of. Cecilia Payne had just explained what stars are made of, and by extension, she had begun to explain what the universe is made of. She was 24 years old. She sent her thesis draft to Henry Norris Russell. Russell was the most prominent astrophysicist in America, director of the Princeton Observatory, a titan in the field. Her thesis required the approval of senior figures before it could be published and her doctorate awarded. Russell read it. He told her that her central finding, the extraordinary abundance of hydrogen, was clearly impossible. He told her that stars could not be made mostly of hydrogen. It contradicted everything that was known. The consensus was that stars resembled Earth. He was certain of this. He was also, at the time, working on his own analysis of stellar composition. Russell told Cecilia to add a disclaimer to her thesis, to describe her hydrogen result as spurious, to write that it was almost certainly not real. She did it. She wrote those words about her own correct finding, in her own thesis, because she needed Russell's approval to receive her doctorate, and he would not give it without the retraction. The thesis was published in 1925 with the disclaimer intact. The most significant finding of her career was buried in her own words. Astronomer Otto Struve later described stellar atmospheres as the most brilliant PhD thesis ever written in astronomy. With the disclaimer in it. 4 years passed. In 1929, Henry Norris Russell published a paper on the chemical composition of stars. He used different methods. He reached the same conclusions Cecilia had reached in 1925. He cited her. Briefly. His paper noted that his results for hydrogen agreed remarkably well with hers. He did not state that he had originally told her she was wrong. He did not state that she had reached these conclusions 4 years before him. The astronomical community credited him with the discovery. The man who had forced Cecilia to call her findings almost certainly not real was now celebrated for discovering what she had found first. To the end of his life, Russell never admitted publicly that he had told her she was wrong. In 1976, 3 years before her death, Cecilia Payne-Gaposchkin received the Henry Norris Russell Prize, the most prestigious award in American astronomy. Named for the man who buried her work, she accepted it. After her thesis, Cecilia stayed at Harvard. She had no official position. For years, she worked out of Shapley's equipment budget. Not a salary line. Equipment. She was categorized the same way as a spectrograph or a telescope. Harvard President Abbott Lawrence Lowell declared that Miss Payne should never have a position in the university while he remained in office. He was in office until 1933. She kept working. The courses she taught at Harvard were not listed in the course catalog until 1945. She had been teaching for over a decade. Students attended. They learned. The institution refused to formally acknowledge that she was teaching them. In 1938, 15 years after she arrived, she was given the title of astronomer, not professor. Astronomer, an acknowledgement that she existed and performed research. In 1934, she met Sergei Gaposchkin, a Russian astronomer she helped rescue from Nazi Germany. They married and had 3 children. She continued to work throughout, often bringing her children to the observatory. She and Sergei collaborated on variable star research. They accumulated over 3 million observations of variable stars. This data became foundational to understanding how stars evolve and die. She published continually. Stars of High Luminosity, The Galactic Novae, Introduction to Astronomy, Papers on Spectroscopy, Stellar Evolution, Variable Stars, Novae, a body of work that reshaped multiple subfields of astrophysics. None of it came with the title of professor. In 1954, Donald Menzel became director of the Harvard Observatory. He supported her promotion. In 1956, 31 years after she submitted the most important thesis in the history of astronomy, Cecilia Payne-Gaposchkin became the first woman promoted to full professor through the regular faculty process at Harvard University's Faculty of Arts and Sciences. The New York Times ran a small item. She also became the first woman to chair a department at Harvard. Her students included Frank Drake, who developed the Drake equation for estimating intelligent life in the universe, and Helen Sawyer Hogg, who became one of Canada's most distinguished astronomers. She supervised Frank Kameny, who went on to become a foundational figure in the American gay rights movement. She shaped the next generation of scientists, while the institution that employed her spent 3 decades refusing to formally acknowledge her existence. She retired in 1966. She kept publishing until 1978. She died on December 7, 1979, in Cambridge, Massachusetts. Here is what Cecilia Payne-Gaposchkin discovered. The universe is not made of what we thought. 98% of the observable universe, by mass, is hydrogen and helium. The elements that build planets and rocks and human bodies, iron, silicon, carbon, oxygen, those are the trace elements, the 2%, the rounding error. Everything you see when you look at a star is almost entirely hydrogen and helium. Every star you have ever seen is a nuclear furnace converting hydrogen into helium, releasing the energy that lights every sky that has ever existed. The fact that stars are powered by nuclear fusion of hydrogen, the central fact of stellar physics, follows directly from Cecilia Payne's discovery. You cannot understand how a star works without her 1925 thesis. The composition of the Big Bang itself, the primordial hydrogen and helium that formed the first stars, aligns with her calculations. Ratios of hydrogen and helium measured in the Milky Way galaxy today match what Cecilia Payne wrote down in 1925. She was not wrong by a little. She was correct to a precision that holds a century later, and she was told to write the word spurious next to her own finding. In her autobiography, she wrote, "Do not undertake a scientific career in quest of fame or money. There are easier and better ways to reach them. Undertake it only if nothing else will satisfy you, for nothing else is probably what you will receive. Your reward will be the widening of the horizon as you climb." She was not being humble. She was being precise. This was her life. The widening horizon. The pursuit that could not be stopped. The discovery that rewrote the universe belonged to a 24-year-old woman who was then told to deny it in writing. Henry Norris Russell got the credit. She got an asteroid. Asteroid 2039 Payne-Gaposchkin, discovered in 1974. There is also a volcano on Venus named for her. The record is incomplete. It has always been incomplete. We put her back in it. Every video on this channel is a resurrection. If this one mattered to you, subscribe. More than 100 women are in the archive, and a new one surfaces almost every day. The link is in the description.